In the last video we had this motion, and using the equation for the instantaneous velocity, we plugged in x and differentiated, and that gave us the train's instantaneous velocity. By the way, people usually just say velocity instead of saying instantaneous velocity every time. So if you hear someone say velocity, just think instantaneous velocity. If you want to talk about average velocity, then you have to say average velocity. Let's plot the train's velocity on a velocity time graph. Using the equation we got from the last video, Vx equals 2t, we can plot the velocity time graph. It looks like this. Cool, it turned out to be very simple. The velocity is just increasing linearly. Let's look at another example. Say the train's motion is given by this equation. We're going to start the train from t equals minus 2 seconds this time. So that means that the train is starting at 4 meters, which you can get by just plugging minus 2 into the equation for x. And to get the velocity, we just plug it in and differentiate. Hopefully you remember the sum rule in differentiation, which says that we can differentiate both terms of a sum separately. So we're going to do that. And the answer is minus 3 times t squared plus 2. Which looks like this. Let's go back to the train one more time, and let's say the train has this kind of crazy motion. And let's suppose that we're not given the equation of this displacement versus time graph. Since we don't have the equation for the displacement versus time, we're not going to be able to calculate the exact velocity versus time, but we can eyeball it and come up with something that's reasonably good. Let's start with an easy point. At this point, the slope is 0, which means that the velocity is 0. So I'm going to mark that on the graph below, the velocity versus time graph, as 0. Also at this point, the velocity is 0. Mark that also. I'd also say at the beginning, the slope looks to be 0, so I'm going to mark that too. At this point, the slope is positive, so I'm going to put a point down on the velocity graph. At this point, the slope is very negative, so I'm going to put a point way down in the negative of the velocity graph. Then at this point, the velocity is 0 again, and then the velocity becomes positive at this point. So I'm going to connect the dots, and the velocity time graph is going to look something like you see here. Let's watch the train again to see how accurate our eyeballing was. Now if you compare this to what I thought it was going to look like, you'll see I did some pretty good eyeballing.